Okay, so finally, Floyd-Warshall. So you get slightly different presentations of Floyd-Warshall in the textbook and from Wikipedia. The presentation in Wikipedia is possibly slightly nicer, but more complicated. So I'm going to try to give you the intuition using, this is at least the example graph in my version of the textbook, which is from the 90s. So it's from back before Stein. CLRS, yeah, back before before Stein joined as a co-author. So the idea of the Floyd-Warshall algorithm is conceptually, you're going to build matrices that say how far, what is the shortest path from vertex I to vertex j, but so the kth vertex, the kth matrix will say what is the shortest path from vertex I to vertex j that only goes through intermediate paths from that only goes through intermediate vertices from 1 to k. Okay, and so you'll use the matrix for k to build the matrix for k plus 1. So this is dynamic programming. So well, let's start out with building the distance matrix where you don't have any intermediate vertices. So that's pretty easy. So here we have 5 vertices. So from 1 to 2 is distance, 1 to 1 is distance, well, actually, okay, I guess I'm going to write 0. From 1 to 2 is distance 3. From 1 to 3 is distance 8. From 1 to 4 is infinite, because there isn't a one edge, isn't a way to go from 1 to 4 in one step. And 1 to 5 is distance minus 4. 2 to 1, you can't. 2 to 2 is distance 0. 2 to 3 is infinite. 2 to 4 is 1. And 2 to 5 is 7. 3 to 1 is infinite. 3 to 2 is 4. 3 to 3 is 0. 3 to 4 you can't do. And 3 to 5 you also can't do. 4 to 1 is 2. 4 to 2 you can't do. 4 to 3 is minus 5. 4 to 4 is 0. 4 to 5 you can't do. 5 to 1 you can't do. 5 to 2 you can't do. 5 to 3 you can't do. 5 to 4 is cos 6, and 5 to 0 is 0. Okay, so this is these are the distances when you have no intermediate vertices. Actually, I'm just going to stop and check against the book to make sure that I'm not doing I'm not making a mistake so far. Okay, so that's apparently I haven't copied anything down wrong, so that seems to be what the book gets as well. So let's see, how can you get from I to j only using intermediate vertices at most 1. Okay, so that's going to be so what are we doing? Well, we're going to be making these matrices. So for k equals 1 to n, and then for I equals 1 to n, and for j equals 1 to n. How do we compute? So at the beginning, k is going to be 1, and we suppose that we start with this matrix. So how are we going to compute the distance from I to j using using at most intermediate vertices at most one? Well, it's going to be either you go straight from I to j, and you don't go through an intermediate vertex, or you go from I to 1 and then 1 to j. Okay? Because we assume you don't have negative weight cycles. So this is going to be min of, and what is the notation? So let's suppose that this is, what is the notation in the book? How do they write this? They write D, oh, okay. So they call this D0. So this is going to be D K minus 1 I j. And then it's going to be D K minus 1 I to K plus D K minus 1. Okay, that doesn't quite fit. Plus D K minus 1 K to J. And 4 and 4 and 4. So this is the way it does in the book. So the way in the book is going to use a lot of extra space, although you can, because it's going to use k of these matrices, so it's going to use roughly n cubed space, unless you're careful and you free the matrices once you're finished with them. Because once you're done, once you've constructed D1, then you can get rid of D0. So let's see how in Wikipedia it's presented. You reuse the same matrix. You don't even have two matrices. You're just using the same matrix. It works, but it's maybe a bit harder to wrap your head around. So what are we doing where we're saying, okay, the distance, if we're only allowed to use intermediate vertices, 1 is the only allowed intermediate vertex, then we can either go straight from I to j, or we can go from I to 1, and then in one step, and then from 1 to j in one step. Because if there are no negative no negative weight cycles, then always the shortest path is to go directly. So you would go I to 1, either I to j or I to 1, and then 1 to j. So we take the min of these two things. So let's compute D1. So okay, so 1, 1 is going to be a bit silly because it's going to be, well, it's going to still be 0. Because what is the minimum cost of going from 1 to 1? It's 0. And what is the cost of going from 1 to 1 plus the cost of going from 1 to 1? Well, it's 0. So now what is the cost of going from, 1 to 2 is the cost of going from 1 to 2 directly plus the cost of going from 1 to 1. So for 1, this doesn't change. 3, 8, infinity minus 4. And for the first column, the cost of going to 1 is not going to change. Because you're only allowing it to go, you're not really allowing it to do anything different. It was going to go to 1 anyway. So now, what is the cost of going from 2 to 2? Well, that's the same, because it's the min of the cost of going from 2 to 2, which is 0, and the cost of going from 2 to 1, which is infinite, plus the cost of going from 1 to 2, which is 3, so it's infinite. Okay, cost of going from 2 to 3 is the cost of going, oh, okay, so you can't, we can fill in this line isn't going to change because you can't go from 2 to 1. Okay. So it's going to be infinite, oh, sorry, 2 to 2 is 0, 2 to 3 is infinite, 2 to 4 is 1, and 2 to 5 is 7. So it's actually only going to get interesting in the case of fourth. Yeah, it's only going to get interesting in the case of the fourth row because only 4 can go to 1. So we can fill in infinite 4, 0, infinite, infinite, and now, so we've already filled in the cost of going from 4 to 1. It didn't change. So now let's look at the cost of going from 4 to 2. Well, the cost of going from 4 to 2 is the min of the cost of going from 4 to 2 directly, which is infinite because you can't. The min of that and the cost of going from 4 to 1 plus the cost of going from 1 to 2, which is, in total, is 5. So the min of infinite and 5 is 5. And then the cost of going from 4 to 3 is the min of the cost going directly, which is minus 5. And the cost of going from 4 to 1, which is 2, plus the cost of going from 1 to 3, which is 8. So it's the min of minus 5 and 10. And so it's minus 5. Cost of going from 4 to 4 is the min of going from 4 to 4, which is 0, and the cost of going from 4 to 1, plus the cost of going directly from 1 to 4, which is infinite, so this is still 0. And then cost of going from 4 to 5 is min of cost of going directly, which is infinite, because you can't. And the cost of going from 4 to 1 plus the cost of going from 1 to 5, which is minus 2. Now, cost of going from 5 to 1, you can't. Cost of going from 5 to 2 is, well, actually, you can't go from 5. Since you can't go from 5 to 1, this line isn't going to change either. This is a 6. And this is it. Okay. So that should be D1. Let's just check to make sure we haven't written anything down wrong. And 7. Okay. So the only thing that actually changed was that you could go from 4 to 2 in 2 steps, whereas before you couldn't do it. So I think that's the only change between these 2 matrices. So now that we have, remember I said that if you're careful, you don't need this anymore. So now what can you do if now you're allowed to go, if you're allowed to use 1 and 2 as intermediate vertices? So you want to know the cost of going from I to j, and you're allowed to either go from I to 1 and then to 2 and then to j, or from I to j and from I to 2 and then to 1, except you can't actually do that, or from I just to 2 and then to j, or from I just to 1 and then to j. So how do you work this out? This is going to be D2. So again, it's just the same thing now, but now you're going to build it on top of this. So So we're going to run through here. So from I, so I is 1. So we're going to say, okay, the cost of going from 1 to 1 plus the cost of going, so what is the cost of going from 1 to 1 when you're allowed to use 1 and 2 as intermediate vertices? Well, this actually doesn't change. What is the cost of going from 1 to 2 when you're allowed to use 1 or 2 as well, this is still 3. So it doesn't, allowing yourself to use 1 and 2 as intermediate vertices doesn't change the cost of going from 1 to 2. What's the cost of going from 1 to 3? When you're allowed to use 1 or 2 as intermediate vertices, well, you can't get from 2 to 3, so this is still going to be 8. So what is the cost of going, okay, what is the cost of going from 1 to 4? This gets a bit more interesting. Now you're allowed to go from 1 to 4, and you're allowed to use 2 as an intermediate vertex. So it's going to be the minimum of infinity, which is the cost if you're only allowed to use 1 as an intermediate vertex. And the cost of going from 1, so here the cost of going from 1 to 2, which is this, using at most 1 as an intermediate vertex. And then the cost of going from 2 to 4, using at most only 1 as possible intermediate vertex. So in this case, it's direct. So this is now cost of going from 1 to 2, cost of going from 1 to 2, cost of going from 2 to 4. So it's min of infinity and 4, which is 4. Now, cost of going from 1 to 5 is going to be min of cost of going from 1 to 5 directly, which is minus 4. And cost of going from 1 to 2, which is 3, and then 2 to 5, which is 7. So you could go 3, 7, or you could go minus 4. Okay, so it's the min of minus 4 and 10, which is minus 4. So cost of going from, let's just do like one more row. Okay, cost of going from 2 to 1, using at most 1 and 2 as intermediate vertices, as well as the cost of going from 1 to 2, using at most 1 as an intermediate vertex, which is infinite, and 1 to 2 directly, or from, okay, so going from 1 to 2 using it, this actually doesn't change. Going from 2 to 1 doesn't allow it. Okay, this is still going to be 0. Cost of going from 2 to 3, where you're allowed to use 1 as an intermediate vertex. So that's going to be min of going from 2 to 3 in this matrix, and then going from 2 to 2, and then going from 2 to 3. Oh wait, no, 2 to. From 2 to 2 in this matrix, and then going from 2 to 3, which is still infinite. So cost of going from 2 to 4. So it's going to be cost of going from 2 to 4 in this matrix directly, which is 1, and then cost of going from 2 to 2 and going from 2 to 4. So this doesn't change. So actually this row doesn't change, so maybe we should do another one, because this row is 2. So cost of going from 3 to, okay, from 3 to 1 is not going to change, because 2, it doesn't help you, so it's cost of going from 3 to 1 directly, cost of going from 3 to 2, plus cost of going from 2 to 1, which is, so it's still infinite. Cost of going from 3 to 2 is cost of going from 3 to 2 directly, cost of going from 3 to, so this is still 4. Cost of going from 3 to 3, 0, cost of going from 3 to 4. This one is a bit more interesting because now you can say, okay, cost of going from 3 to 4 directly is infinite, or cost using only 1 as an intermediate vertex, either going directly or using 1 as an intermediate vertex, the cost is infinite. And then but now you're allowed to go from 3 to 2 and from 2 to 4. So the cost is 5. Okay, the sum of these is, so it's the min of infinite and 4 plus 1, which is 5. So finally something changed. And then cost of going from 3 to 5 is min of going directly or using only 1 as an intermediate vertex, which is infinite, and cost of going from 3 to 2, and then from 2 to 5. So this is min of infinite, and then 4 plus 7 is 11. So this also changed. Okay, so, and then we do the rest of this. We fill in the rest of the matrix like this. The sneaky thing in Wikipedia is that they're actually overwriting the matrix as they're going. And you have to think a minute about why you can do that without messing yourself up, but it's because it's converging. All of these entries are converging, so even if you get a bit ahead of yourself, it doesn't matter. And probably, I'm not even sure if you can get ahead of yourself doing this. So they actually don't have these superscripts, they just have one matrix. Okay. So that's Floyd-Warshall. It says in the book that how to actually recover the paths. Basically, you just store little annotations about when you compute these things, you keep track of which of these, when you took them in, which of these is better. So it's a fast algorithm. So remember the matrix multiplication, we were doing repeated squaring, and this took a long time, and then we were doing so it wasn't matrix multiplication, but it was like matrix multiplication, and we were taking the min plus, yes, min plus. So instead of doing plus times, we were doing min plus. But so that, if we were doing that, then for the repeated squaring, that added a log factor, and the matrix multiplication, we were doing it in cubic time, each one. So that was giving us n cubed log n. And now we're just going, this takes constant time. So we're going to go through and use n cubed time. So it's a bit better. So that's 23 minutes. So there is a question on the assignment about Floyd-Warshall. So there are lots of resources to find out about Floyd-Warshall. And okay, 24 minutes. This is probably a good place to stop, so I'll see you in a minute for shortest paths in a DAG.